For the first question, we have three equations given, which is national income identity, consumption function, where we can insert disposable income, y minus t into yd, and tax function. Now we want all endogenous variable y, c, and t on the left-hand side, while all the constant on the right. For the first one, we move c to the left. For the second equation, we need to expand b first, and then move those with endogenous variable to the left. For third equation, we move ty to the left. That leaves us with three equations. The second question asks to transform the three equations into matrix form. In the matrix equation, the left-hand side consists the coefficient matrix multiplied by the vector of endogenous variables, while the right-hand side contains the vector of constant from the three equations. Note that we put 0 for equation that does not have the endogenous variable.
My name is Victoria Grace Anak Koyat, matrix number 309310. For my part, I will explain how to solve this system of equations using the matrix inversion method. First, we write the system in matrix form as AX equals B. To solve for X, we multiply both sides by the inverse of matrix A. This gives us X equals A inverse times B. Next, matrix A is defined as a 3 by 3 matrix. In the first row, the elements are 1, -1, and 0. In the second row, the elements are negative B, 1, and B. In the third row, the elements are negative T, 0, and 1. Before finding the inverse of matrix A, we must first calculate its determinant. The determinant of A is calculated using expansions along the first row. After simplifying, the determinant is 1 minus B plus BT. Since the determinant is not equal to 0, the inverse of matrix A exists. Next, we find the cofactor matrix of A. Each element of the cofactor matrix is obtained by finding the minor of the element and applying the correct sign. The cofactor matrix consists of 1, B plus BT and T in the first row, 1, 1 and T minus BT in the second row, and B, B and 1 minus B in the third row. Then, we find the adjugate of matrix A by taking the transpose of the cofactor matrix. The adjugate matrix has 1, 1 and B in the first row, B times 1 plus T, 1 and B in the second row, and T minus BT and minus B in the third row. Using the formula A inverse equals 1 over the determinant times the adjugate of A, we substitute the determinant and obtain the inverse of matrix A. Next, vector B is defined as a column vector consisting of I0 plus G0, C0, and T0. We then multiply A inverse by B to obtain the solution vector X. This gives us the equilibrium values of income, consumption, and taxes. The equilibrium level of income, Y star is equal to 1 over 1 minus B plus BT multiplied by I0 plus G0 plus C0 plus B T0. The equilibrium level of consumption, C star is equal to 1 over 1 minus B plus BT multiplied by B times 1 plus T times I0 plus G0 plus C0 plus B T0. The equilibrium level of taxes, T star is equal to 1 over 1 minus B plus BT multiplied by T times I0 plus G0 plus T minus B, T times C0 plus 1 minus B times T0. In conclusions, by using the matrix inversion method, we are able to solve the system of equations and obtain the equilibrium values for income, consumption, and taxes. And thank you. That's all from me.
My name is Alvina Fiona Anak Romi, and my matrix number is 309476. Now I will explain C2 of our analysis, where we use Cramer's rule to solve a system of the three equations. Our goal is to find the equilibrium values for income, consumption, and taxes, which we call Y star, C star, and T star. The fundamental formula for Cramer's rule is simple. we take the determinant of the modified matrix and divide it by the determinant of the original coefficient matrix modulus A. Before solving for individual variables, we must find the determinant of the system A modulus. As shown in the previous question, our determinant is y minus b plus b. This value is crucial because it acts as the common denominator for all our solution. If this value were 0, the system will have no unique solution. Now let's look at how we find the numerators. To find y star, we create matrix A sub y by replacing the first column with our constant, which include exogenous variable like investment, I0, I0, and government spending, G0. After expanding the determinant, we get the expression for income. To find C star, we move to the second column. We replace it with our constant to form A sub C. Notice that the algebra gets slightly more complex here as we account for the marginal propensity to consume, which is P. And finally, for taxes T star, we replace the third column to form A sub T. By dividing each of these specific determinants by our original A modulus, we arrive at these three final equilibrium formula. This equation allows us to see exactly how a change in government spending, G0, or tax rate, T, will impact the entire economy. For example, in the Y star formula, we can see how the multiplier effect is captured in the denominator. And let's conclude the derivation using Cramer's rule. That's all from me. Thank you.
My name is Nur Aisyah Lena binti Ismail Bungsu. My matric number is 309431. Okay, so now I will explain question C number 3. In this question, we need to use variable substitution method to find the equilibrium value of income, Y, consumption, C, and tax is T. Okay, so first I start with, I write down the three basic equation, which is Y equal to C plus IO plus GO, and C equal to CO plus B, open bracket, Y minus T, close bracket, and T equal to TO plus TY. Okay, next, we need to substitute the equation 3, tax equation, into the consumption function, equation number 2. Okay, so since the tax T equals to TO plus TY, so we need to replace T in the equation number 2 with TO plus TY. So this gives C equal to CO plus BY minus BTO minus BTY. Okay, after that, we need to substitute consumption equation into the equation 1. Okay, so we use the equation C that we get back then to equation number 1. So it will get Y equal to CO plus BY minus BTO minus BTY plus IO plus GO. And then we need to rearrange the terms so all of Y terms are collected on the left side. Okay, so we divide it and we can get Y, open bracket, 1 minus B plus BT equals to CO minus BTO plus IO plus GO. Okay, so
we bring back the we bring the 1 minus b plus bt into the right back, so it will equals to y equals to co minus bt minus bto plus io plus go divided by 1 minus b plus bt. Okay, finally I substitute the value of the equilibrium value of y into the consumption equation and tax equation. So from that we can get the equilibrium value of C and T. So lastly, I write down all the equilibrium value of y, c, and t. So y we can get y star equal to co minus bto plus io plus go divided by 1 minus b plus bt. C star we can get equal to co plus b open bracket value of y and close bracket minus bto minus bt open bracket value of y close the bracket. Okay, and lastly is t star which means to plus t open bracket value of y2, okay, or close bracket. So that's the final answer of equilibrium value for income, consumption, and tax by using variable substitution method.